it? We're trying to find the.
So let me ask you this. If this angle was 0,
So
if this angle right here was 0, what would the magnitude of A be? This thing's 300 here. 300. 300. So you'd just be pointing in the y direction at that point. Right? So it'd be all of it. So what's something that when you take trig increment, trig function of 0 equals 1, what trig function would that be?
Cosine.
Yes, that would be the cosine. So we're going to take the cosine of our 70 degrees right here times cosine of 70 degrees. And that happens to equal 103 newtons in each direction. So that's how long this guy is. And so now we want to know B. We want to know how long B is. For B, we're not going to get an actual vector, we're just going to get the magnitude of it. So what's the magnitude of B? Okay, so we know how long this one is, we know how long that one is, which you don't even need to know this. Let me ask you this. If this was 90 degrees, this angle, okay, what does that mean? If F is 90 degrees, or the angle between F and the Y axis is 90 degrees, what does that mean? Just in English. It's in the XZ plane. It means it's in the XZ plane, which would mean that how long would B be if this was 90 degrees? 300 newtons. Right? This is the projection of F in the XZ plane. So if this thing is actually just in the XZ plane, then it's got the same length. And so what is a trig function that you take a trig function of 90 and you get 1? That would be the sine. So that's what we're going to do here to find the magnitude of B. And as I say magnitude, because we don't know what direction B is really going. Okay, we're finding the length of it, okay, we're doing that. We don't really know the direction it's going. So the magnitude of B here, once again, are 300 newtons, this time times the sine of the 70 degrees. And so that equals 282 newtons. So that's the length of B. So now we still need to find our I and our K components. J we're done with. We've got J. That's it. We need to know how much this guy is in the X direction, how much in the Z direction. So let's start with, say, the I, or the X direction, the I unit vector. What am I going to do here?
282 times the cosine of 20 degrees.
So is the cosine of 20 degrees a positive number or a negative number?
Sine of 20 degrees.
I think it's a cosine. It's headed the right way. Positive. And is this B going in the positive or negative X direction? Negative. So what we can do with this, and there's lots of different ways to skin this. If you look at it, you could just say, so we're going to do it between the x-axis. We want to know how much is in the x. So this is 20 degrees. So that means that must be 70. Right, as far as the angle in the XZ plane. So we could say it's negative. Take the cosine of 70, which would be a positive number, and then just take the negative of it. So we take negative cosine of 70. That would work. What we can also do is we can measure around from this guy, from X, and so this is, I'm measuring in the XZ plane around here. And so what would that angle be? Yeah, so that'd be 250. So we can take the cosine of that guy, just straight up. Because the cosine of 250 is a negative number, which is what we want. So that's what I'm going to do. So I'm going to say F in the I direction equals 282, so that's the length of B, magnitude of B. 282 newtons times the cosine of 250 in the I direction. So that equals negative, what we expected, 96 newtons in that direction. So now we've got our got an angle. I want to know how much that is, how much that is. For this one we use cosine. This is going to be the cosine, and this one's going to be the sine of theta in each case, right? And so we use the same angle, and all we do is for I we use cosine, for j we use the sine, and we're then we'll work with that for this. And we'll work with this for this. We can't just go, oh, we want to know K, we're going to do F, so K equals 202 newtons, just swap in sine, sine 250, J, here we go. It's not going to work. And the main reason it's not working is we're skipping a vector. We're going from I to K, we skip to J. So with the right-hand rule, you kind of got to go in order. So going from I to J, that works. If we were going from J to K, it would still work. If we were doing from K to I, we're going to get to this sort of distorted later. But that would also work. But in this case, when I'm doing that, we're skipping around. So this is back to where I say you just have to kind of think about it. So is B going in the positive or negative z direction? It's going in the positive z direction. And if this angle were 0, all of it would be in the z direction. Right? And so cosine of 0 would be 1. And it would be positive. So if we take the cosine of this angle, cosine of 20 degrees, and multiply it by the magnitude of b, that's going to give us how much is going in the z direction. Does that make sense? Okay. We're doing this on homework. Alright. I gave you, I believe, 3 vectors. Yeah. I give you 3 vectors. You're going to be doing this little process for all 3 of them. So let me show you that. Hey, you really feel Isaac. Alright, so we got F in the K direction equals our 282 newtons, that's the magnitude of B. So like I said, this time it's cosine of 20 degrees. I wish I could give you a cookbook for that, but I said you just gotta come think about it and see what makes sense. What's gonna give you the result you want. And that's literally what I do. It's like, okay, should be positive, and I think about, well, if this was 0, it would be 1. If it was 90, it'd be 0. If it was 90 degrees, it would be 0. That's cosine. That's how you use cosine instead of sine. That's literally how I figured this one out. This is in the K direction. And so that equals 265. Okay. And so this is our vector right here. Our vector F. Yeah. Good point. Newtons in the K direction. This one didn't have a vector, this is just a magnitude. So if we want to have F, we write F out. So F equals, here we go. It equals 103 newtons I, then that's J. Negative 96. There we go. Negative 96 I, and then plus 103 newtons J, and plus 265 newtons K. There we go. That's our vector in broken up into the unit vectors I, J, and K. So now we can algebraically solve this if only we had already done it for that one. So now we're going to do it for that one. Big deal.
So it says on the homework is write it, part A says write the vector in terms of I, J, and K. That's what you want right there.
Yes. Thank you for bringing this, Isaac. It's actually part 2. Yeah, part 2A says express each in I, J, and K notation. Yes, this is what I want. So you're doing this exact process we just did with 3 vectors. P, Q, and S. And then you're doing dot products, so a couple dot products and cross products.
Thank you.
Right to it. And this is the biggest part of it. Getting the I, J, K. The dot product, certainly the dot product isn't too bad. Even the cross product isn't too bad. You'll hate it when you first see it, but So B is the projection. In this case, this thing's going in the negative y, so it's
Yeah.
what's happening. That's why A is coming down. We project over on B and then came down, whereas here we projected over and went up. This one's going in the negative y direction. It's going in negative x direction, negative y direction, positive z direction.